79 explained rather quickly. This is about the hardness of the tablets. All right, our null hypothesis is that the tablets have a average hardness of 11.5, okay, mu. And off to the side, I should explain what mu is. Mu, average hardness of all tablets. And the alternative is that it's not. This is a two-sided, because we want to see if our expectation of 11.5 is met, or do we have evidence that it's not met? So mu is not equal to 11.5. First thing we should do is check our conditions. Random, they said it was a random sample. Independent, we can assume there's more than 200 tablets, right? 10 times our sample size. And normal, well, for means, we need to have over 30. The central limit theorem says if it's over 30, you're all set. Otherwise, we've got to look at the graphs. So if you look at the histograms, the histogram of your 20 samples, you'll see that your sample of size 20, you would see that the graph is symmetric, no crazy outliers. Really, as long as it is not incredible skewness, you're all set. Okay, so you put it all into your calculator, into your list, and then you do one bar stats, and you get the sample mean, X bar, was 11.516, and it deviated by 0.095. Okay. And I drew a little curve here. So if the null is true, we would have an average of, if we did this many, many times, samples of 20 would be centered with an average of 11.5. But in our sample of 20, we got 11.516. So it really doesn't seem like that's really close to 11.5. So probably we're fine, but we're going to do this all out, right? So 11.516, how likely is it that we would have gotten that if the null is true? We would have gotten that or more extreme in either direction, because this is two-sided. All right, so we want to find our t-score, which, as we know, is our value, our statistic, minus our parameter, divided by how much we think that statistic should vary, the standard deviation of our statistic, which is s of x over square root n. Okay, and this is a t-test, or this is we need to find, it's going to be a t-distribution because we have, we're using the sample standard deviation. When we do that, it doesn't follow a normal curve. Okay, so putting in those values, 11.56 minus 11.5 divided by that s of x over square root 20, we get 0.76. All right. So 0.76, that's the likelihood that we would have been, that's how many standard deviations off this is. So 0.76 is the chance, is not the chance, is how many standard deviations 11.516 is. It's 0.76 standard deviations above. So how likely is that to have occurred by chance? Well, that's where we go to our TCDF. TCDF 0.76, 99, 19. So we have 0.76 standard deviations above to 99 standard deviations above with degrees of freedom 19. That gives us 0.228. Multiply by 2 because it could be this side or this side, and it gives us 0.456. That's the p-value. Okay, now in the p-value, we need to make a we can conclude from that our p-value is larger than our alpha. We have no evidence. We have no evidence to reject the null. We can't say the hardness of a tablet is off b. So it's right there. We have no evidence to say the tablets are off the 11.5.